To understand Ethereum, it is helpful to compare it with Bitcoin first. Bitcoin was created mainly as a form of digital money. Its main purpose is to store and transfer value without relying on a central authority. Ethereum was created with a different goal. Ethereum is not just digital money. It is a decentralized platform where financial agreements and applications can run automatically. The key idea behind Ethereum is programmability. This means that money and contracts can be written into code. Once the conditions are met, the code executes automatically. These programs are called smart contracts. A smart contract is like a digital agreement. But instead of depending on a lawyer, a bank, or a company to enforce it, the agreement runs on the Ethereum network. For example, imagine a simple loan. In traditional finance, a bank checks the borrower, sets the terms, holds records, and manages repayment. On Ethereum, a lending system can be built with smart contracts. The rules are written into code. The collateral, interest rate, and repayment conditions can all be handled automatically. This is one reason Ethereum became the foundation of decentralized finance, also known as DeFi. DeFi allows people to lend, borrow, trade, and earn yield without using a traditional bank. Instead of one company controlling the system, the rules are visible on the blockchain. This does not mean DeFi is risk-free. Smart contracts can have bugs. Some projects can fail, and users must understand what they are interacting with. But the important point is this: Ethereum makes it possible to build financial services that operate without traditional intermediaries. Now consider stablecoins. Stablecoins are digital tokens designed to track the value of traditional currencies, usually the US dollar. A token like USDC can move on Ethereum as a digital dollar. This allows people to transfer dollar-based value across borders more efficiently than many traditional systems. For someone sending money internationally, this can be important. Traditional transfers may involve banks, fees, delays, and currency conversion. With stablecoins on Ethereum, value can move directly on a blockchain network. Again, this does not mean the system is perfect. There are regulatory questions, issuer risks, and technical risks. But it shows why Ethereum is not just about speculation. It is also about financial infrastructure. Now consider NFTs. Many people think of NFTs only as digital art, but the broader idea is digital ownership. Ethereum can record who owns a digital asset. That asset could be art, a collectible, a game item, or potentially a membership or certificate. The speculative boom around NFTs created both excitement and criticism. But beneath the hype, the core idea remains important. Ethereum can assign ownership to digital objects. This is one reason people compare Ethereum to the Internet. The Internet made information programmable and transferable. Ethereum attempts to make value and agreements programmable and transferable. Now let's talk about gas fees. Every action on Ethereum requires computation. Sending tokens, using DeFi, minting an NFT, or interacting with a smart contract all require network resources. Gas is the fee users pay to use those resources. When demand is high, gas fees can rise. This is similar to traffic congestion. When many people want to use the same road at the same time, movement becomes slower and more expensive. This has been one of Ethereum's biggest challenges. If transaction fees are too high, ordinary users may avoid using the network. That is why scalability is so important. Ethereum has been developing upgrades and Layer 2 networks to make transactions faster and cheaper. Layer 2 networks process activity more efficiently while still connecting back to Ethereum. This is part of Ethereum's long-term development. Now let's look at Ethereum from an economic perspective. Bitcoin is often described as digital gold because it focuses on scarcity and value storage. Ethereum is different. Ethereum is more like a decentralized operating system for financial applications. Its native asset, Ether, is used to pay for activity on the network. So Ether is not only a tradable asset, it also has utility inside the Ethereum ecosystem. The more people use Ethereum applications, the more important the network becomes. This is called a network effect. A network becomes more valuable as more users, developers, and applications join it. This is similar to how the internet became more useful as more websites, users, and services appeared. Ethereum's value depends not only on price speculation. It also depends on whether people continue building and using applications on the network. But there are risks. Ethereum faces competition from other blockchains. It faces regulation from governments. It faces technical challenges related to speed, cost, and security. And like all crypto assets, it remains volatile. So Ethereum should not be understood as guaranteed future money. It should be understood as an experiment in programmable finance. The key question is not simply whether Ethereum's price will rise. The better question is whether programmable money and decentralized applications will become important parts of the financial system. In summary, Bitcoin introduced the idea of decentralized digital money. Ethereum expanded that idea into decentralized digital infrastructure. Bitcoin asks, can money exist without a central authority? Ethereum asks, can financial systems run without traditional intermediaries? That is why Ethereum is often called the Internet of Money, because it is not just trying to move money. It is trying to make money programmable.